Yeah, so my name's Seth Roope. I'm the procurement manager for the Carrier Group. I mainly deal in softwood logs. I take care of the three mills that are listed on the screen there, Milan Lumber, Luzon, and our brand new flagship mill that's 100% studwood. We only service studwood in that particular mill. The other two are more your traditional sawmills that cover from 8 foot all the way up to 16 foot. I've been with the Carrier Group for just over 4 years now. I've been buying for Richard and Jimmy, and I'll give you a little bit of a rundown about how we take Scott's product that he's producing in the woods and transition it into a mill and make something that we can actually sell and create some sort of a product on most of the time. So I'd like to go through kind of like how that mill works from start to finish, how the logs come in, how we process them throughout the whole system that we have. And like I was telling some of the people at our table, this mill will literally fit in probably a third of this space if you were to put it all down. It's very small, very efficient, and the key being a low labor force to do it. We'll discuss some of the challenges, the opportunities that we have with this particular mill using these particular products. The products themselves, what I produce, what we try to, bigger is always better in the sawmill world for us as far as pricing. So we're trying to maximize size over quantity most of the time. We'll talk about a little bit about some of the niche markets that we work with. And as probably everybody's run into, labor efficiencies. Labor has been a massive problem since pre-COVID for any one of those mills that were listed on that screen, and some of our hardwood mills as well. And then how we, as that being a brand new mill, how did we solve some of those problems of not having the skilled labor or just general labor at all? And then little questions and answers there. So what are small diameter logs? Well, we call them, this particular mill max out at 10 foot 6. It cannot take an 11 foot log. It will not run through the system the way it's designed. So we're calling anything 10 foot 6 and below. The spec says 4 inches, but I don't know how many loggers or operations foresters are here. It can handle 3. But once again, it goes back to the previous statement. I need to make a 2x4, and I can't do that in a 3-inch top diameter log. So, like I said, our goal is it's kind of its sweet spot, which most mills have, is between probably 5 and 6 inches. If we could average that, is when we're making the right amount of small diameter or small dimensional wood and with the larger dimensional wood to make that the profitability thing kind of work out, the formula. So where do we source the timber? Well, Scott is sourcing it for us in a lot of those pictures that he was discussing. We've been working with Wagner for a few years now, trying to develop a way that works for them and works for us on being able to monetize these tops, really, is what it is, especially with the lack of a active and vibrant pulp market, which there may or may not be in right now. So it's within 75 miles of the mill. Trucking becomes an issue once you start getting out there, and then price points change, and at that point is it really worth it for the loggers to deal with it, and the industrial landowners or the private landowners to deal with it? So I find that most of our wood comes within 75 miles of our mill. First commercial thinnings like Scott does, but it's not the whole tree like Scott was saying. It's literally what we're buying is the tops or the parts that got slashed off or what. 95% of what we buy is probably tops, and if we were going to take a count around. So for a long time, this has been an ongoing problem. My career is not that far along, but my entire career has always been, what do we do with this small diameter wood? It's, if you get a 16-footer or a 12-footer out of it, oh, no problem, we can get rid of it. 8-footer, nobody wants an 8-footer. Nobody's actively seeking out, or had been seeking out, an 8-foot, 4-inch log. So it was a hugely underutilized product. Your only outlet for a long time was pulp, and that was on again, off again, depending on the availability of truckloads and if the mill was even using it at that particular time. So we, discussing it with the carriers, we thought that it has real viability now, especially with this wall of wood, as Scott put it, coming online. There's going to be a tremendous need for this, and if we can find a way to get our mill efficient enough, or build one efficient enough to utilize it, there may be a way to enter into the market in a different way than like Milan or Luzon. Oh yeah, that's right, 6-second delay. I feel your pain, Scott. It's been longer than 6. Oh, there we go. It's going to move again. I hit the button. So Lambert's Mill is located in Woburn, Quebec. We started construction in late 2020. Really started in 2021 by the time you get all the Canadian paperwork and stuff done. And then we completed it in 2024. We were doing tests and stuff in 23, but we were running it in 2024. So like I said before, we have a 10-foot 6 is a maximum diameter. We buy down to 8. We have a maximum diameter of 10 inches. Our debarker is a 12-inch debarker, and the only way we can fit a 12-inch log through it is if it's perfect gun barrel straight. So the spec says 10, just so we can saw with curve, we can do some fancy things with sweep. So the spec says 10, so we can run it through the debarker and then actually make a product up the other end. Like I said, it's 8'6" is the smallest that we do, down to a 4-inch top, with hopefully not too many guys pushing it to 3.5. But we have, so this particular mill is capable of running spruce fir for your normal dimensional lumber. It runs larch for pallet. It also runs hardwood, also for pallet. Poplar's in there too. Sometimes there's some niche stuff we do with poplar, but for the most part it's spruce fir. It's a spruce fir mill, with these things used as either gap fillers, or if we have a market that comes online, that's where we try to, we can move that around depending on what we need. So this is kind of the log flow. This is how a log goes through. I don't know how many of you guys had a Dr. Rice's class, but this kind of brought back some good and bad memories of that. So it's the start to finish of how a log travels through our mill and how we make our products. So we get a log deck, like I said, maxes out at 11 feet, so 10'6" is key there. A series of cranes that haul the timber from our storage facility outside in the yard, and it just manages the flow into the debarker. There's a metal detector like most mills have, trying to find where the bullets are, or old fences, or who knows what's in these trees. So the metal detector comes first. Then we've got our Nicholson debarker. Like I said before, it'll handle up to 12 inches, optimized at 10. Bark removal. Oh, it's moving fast now. You got me all messed up. So then we have our transport system. It's just taking the bark and all the byproducts that are coming from the debarking system. That goes into our byproducts bins to be sold to biomass, and in this case, Berlin or some of the Canadian mills. Then after the debarker, it falls onto log deck. So in our mill, it runs it makes a 90-degree corner, and the 90-degree corner is just to the top right of the first picture before it heads to the Hughes saws. So that spreads everything out. At every one of these stages, there's cameras throughout this whole place. So if there's a log that doesn't look right, doesn't meet spec, it's broke, it's got an issue with it that it should not go through the saws, they can drop it and send it to the chipper by a push of a button. So there's nobody there to like hit a button or make sure all this stuff. It's all done with cameras and automation. So then we come to the heart of the system. So we have a Hughes saw that we actually sourced that during COVID, which was its own nightmare in its own. They're all built in Europe, and we had to work with another mill, a local mill, to try to trade places on who was getting their Hughes saw next. So we were in a crucial point where we needed it to finish the designs and get it installed, so we made sure everything else lined up to it. But it's a single pass log sawing system. So in 5 feet, it goes from round to lumber in very short order. So in the beginning, it's turning that round log into your lumber. It uses a series of chipping heads, which is going to change it from round to square. So in a foot, it makes a cant. In the next foot, it's got a gang of 3 banks of 9 saws that are all, everything in the system is stationary. Nothing within the Hughes saw itself turns or moves. It's all pre-programmed, and whichever saws need to go, it's aimed in that log is aimed in that particular direction. I have a little video here that will kind of show you what I mean. But so as it's transitioning, it goes through a scanner. The scanner comes up with the saw solutions for every single log. So in the first one, we can saw crooked wood. Do we want to? No. Can we? Yes. The example on the first one, it's kind of hard to see in the photo, but the top board is 9 foot, and the bottom board is 8 foot. So in that log, it's saying that, well, we can make this, this, and this out of it, and if we make this log a little bit, or this piece of lumber a little bit shorter, we can get a little extra piece of something out of it. So the computer's reading it, and then it's moving on. Okay, what's wrong with this log? What does it need to do? What does the orientation need to be for it to go through this fixed sawing system? So you get another log. The next picture is the sweep and defect. It's offsetting logs or offsetting lumber to make sure that it's optimizing every merchantable stick out of that little tiny log. Everything we can glean out of it down to 1x3 or 2x3, or it's scanning for that. It even, if you freeze frame each one, you don't usually see it while it's in actual operation because it's moving too fast, but you can pull up any log and it'll show you where the wane's going to be on that log when it spits it out the other end. For the most part, it's like 90% accurate. You can see the dark shapes on the third picture. That's the wane, where it's predicting wane to be on those pieces of lumber. And then the last one is just kind of showing, I think that was a 4-inch top, and we're trying to get, I can't remember on that one, it's 2x4s out of it. The goal is 2x4. Anything under that is a pretty substantial difficulty in sales now and then pricing. But so it's just trying to maximize every little thing we can out of those logs within our specs that we've fed into the system. So moving on, now we have the edger. So this is the final moving part, the saw part. It's taking the chipper heads, bring it down to a square. The saw actually turns it into the general shapes, but sometimes it will have like a 2x4 will be 4 inches. So the edgers are going to come along and take that last inch off in chip format. And then your final 2x4, sawn 2x4, is spit out the other end after it's gone through this. Then we have the sawdust, because this thing is making and I'll discuss this further, a tremendous amount of chips. Just the way it's designed to do. It makes a ton of chips and it makes a ton of sawdust. Then we have our output, so it's just the deck. That's where it's making its 90-degree corner. It spits them out there, they all fall out, and then they start heading down to the trim saws. Trim saws are just going to get it to this final length. It's going to cut off any of the, there's too much wane, or if there's something that doesn't meet spec on one end or the other, it's going to cut off the problem piece and make it the correct length for final sale. So in our system, this is kind of this is the part that saved. It's the most expensive, and it saved. Well, it's the second most expensive behind the Hughes saw itself. But this is the iDNA system. This is a bank of cameras and sensors, either laser or infrared, that on one side. So if you're looking at it on the left-hand side, it's scanning every single log or every single piece of lumber that comes through there, and it's picking out what species it is. If it's spruce, if it's fir, if it's Norway spruce, each one of those different species has a different drying time. We need to keep track of that. We can't mix in fir with Norway spruce because the drying times are totally different. Wood either comes out under-dried or over-dried, and we've lost crucial dollars by either overspending on drying time or ruining a product. So it's scanning to see on the front side to tell the system what is that for a species. When it goes through the other side, on the other side is the auto log system. This is what's doing all of our grading. It's saying whether it's an economy 2x4 or if it's a number 1, a number 2, or number 3, depending on whatever we're running at that particular time. So this has replaced, I'm not sure how many humans could actually, at the speed this thing runs at, tell what species it is going by. I don't know anybody that could. I know I can't. And then on the other side, when it's going, it's also going at a super speed. And I don't know how many of you guys are familiar with how lumber mills work. Up until recently, everything through this system was done by hand. The guy flipping it, looking at everything. He was making judgment call, that's number 1, that's number 2, that's that. That's always has human error involved in it. There's always going to be, well, this guy sees it one way or this guy sees it another, so it's always this chance that you're going to miss something or make a mistake. With the artificial intelligence, it doesn't. It's only going to follow the inputs that you put into it. So we put in our NELMA rules, it follows them, and it gets 99% accuracy, where a human's only good for at best 85. It's also one of the highest paying jobs in the mill, used to be for a grader position. Now it's the second most expensive piece of the mill, but there's no human side to it anymore. He doesn't need a day off, he doesn't get sick, he doesn't anything. So after that, it heads to our sorting system. We got I think there's 37 sorts here. A little further along, I'll show you what Milan looks like, which is our flagship. But 37, so that's quality. It's sorting quality, length, product. It's 2x6, 2x4, so on and so forth. Before it gets packaged and get ready to send to our primary facility, which is in Milan, New Hampshire, Milan Lumber. We don't finish any products here at this particular mill. It's not drying there. It's not packaged there. It's only stored and then shipped down and finished at our other facility. So from the debarker to the iDNA system, there's one guy in a control room. That's his seat. All the banks of cameras, everything's cameras. He can see everything. If there's an issue, he knows where it is. He knows how to fix it. Sometimes he doesn't have to get out of his chair to fix it. It's highly, highly automated. So this is a little video of, I couldn't get any closer, but it's pretty dangerous to be this close even, but this is going to be the opening to the Hughes saw. So like I said before, the chip heads, the blade, the saws, the edger, that's all stationary. They're spinning, but they don't move. They move they move horizontally, but they don't twist, they don't do anything. The computer is saying that to get the maximum amount of volume out of that log, it needs to enter this system at a certain degree. And then it might have to enter this in a certain degree and then be shifted or changed as it goes through, because there's knots and bumps and whatever that can move it around. But it's making a judgment call on, it needs to be at a 45 degree or a 33 degree angle, enter in, turn, and then be sawn. And this will kind of show how is it doing it. I hope it plays anyway. Yeah. It's way cooler when it's playing it at real speed, but I think we're wiping the Wi-Fi out here pretty hard. So anyway, yeah, no, it's really not doing it any justice. I promise it's impressive, but yeah, that sucks. I've got 2 more videos too, so that's awesome. There's another one. So that's the front side. This is the back. It just kind of showed, here's your logs that going through, and this is how they're coming out the other end before they're getting ready to get scanned and make a judgment call on their value and things. But I don't know if this one will play any better, but that's what happens when you try to be fancy. Oops, now I really did it. I'm not doing it again. Didn't like it? That's all right. Did it move to the next slide? I can't tell now. Is it? I'm telling you, this mill's spectacular. It's so fast you can't even see it move. Yep. We're moving that way, really jerkily. A lot. What was that again? Not that I know of. It was the availability of the location and the want and desire of the other part owner that's in it. That's part of the carrier group. He's Canadian from there. He had the ability for the site itself, so it just kind of lent itself to it. And we don't have any more room at Milan to even remotely try to do something like that. So. Perfect. Okay, so now we're done at Woburn, at our Lambert facility. Everything's put on a truck and then it's trucked down to be finalized at our Milan lumber facility in Milan, New Hampshire. So this is kind of the back half of the Milan mill, which is set up completely differently than the Woburn Lambert facility. So they facilitate. We have all the kilns are located at Milan, and we dry a lot of wood. It's a 24 hours a day, 7 days a week, non-stop production. We just had 2 new kilns built 2 years ago to add to this capacity with our purchase of Luzon, and then this facility being built. We needed the extra infrastructure to be able to, and capacity to dry and plane. So this planer system was built, I think it finished 3 years ago. Took 2 years to build. It was an $18 million project, and it has the capability of planing 1 million feet a day. We're not there yet as far as production, thank God, but we're heading there. So you've got the planer, you get the kilns, drying all the wood out to spec, NELMA spec. It's all separated by species, so we dry correctly for the right amount of time, with the right amount of energy being used. The planer in-feed, so everything's offloaded off in the little mini rail cars that are used at the kiln. They're offloaded into the planer when it's time to plane. Goes through a system that dumps it into a carousel, or into a system that spits it into the planers, which you can see there. There's a pair of them. One of them runs full time, the other one's kind of a backup. And then you have the stacker sorter. So this is the kind of the biggest part now. Now we went from something the third or the size of this room to now you can play, almost football field and a half in this building that this planer system's in. If you look in the background, I know the picture's not the best, but it's 172 sorts. We collect everything. We're like little hoarders. If it's 4 foot, we keep it. It's not going in the chipper at all. We'll sell it for something, which is probably better than what we're going to get for byproducts. So, but it's 172 different slots, so we can run anything and run it through, and it has a home. We can collect that as a merchantable product. That was kind of the big piece. We almost doubled our ability to sort stuff in this. Not only are we 1 million feet a day processing capability, but now we have the ability to store it and get it ready for sale. So once it's done within the mill, it's out back. That's where we store everything, waiting for the transport for wherever its new home's going to be. When it's shipped out, all by truck at this point. To I think the furthest I've seen some go, we're going to Juarez, Mexico, for whatever reason they needed it in Juarez. We've sold wood to there, so I thought that was pretty neat. Out back, just to the left of the first picture, there's a big pine tree. It's right on the river there, and there's been an active eagle's nest in this pine tree. It's not even 500 feet probably from the mill. Every year they consecutively raise their young there. And it was actually, while we were doing construction, we had to shut down for 3 months. We weren't allowed to do certain things to disturb the eagles. And I don't know if how many of you guys have met Mr. Carrier or not, but that wasn't really something he wanted or was willing to do, but he did. And for that, he got lots of praise, and he's got cameras all around this place. And if you ever look in his office, 9 times out of 10, he's got the camera zoomed right in. He's watching his eagles. They have little ones right now in the nest, actually. So it's another video of the planer. We'll see if Ray worked his magic on it. Once again, it's way faster than this. But let's just skip along there. I have this if you guys want to see it, or if you want a tour. All my credentials are going to be on screen. Take a picture, call me up, shoot me an email. Be more than happy to take you guys through it, any one of our mills, and give you the full speed version. So with this type of mill, there's obviously challenges, and there's a lot of challenges, and there's been a lot of challenges. Hence, there wasn't very many of these facilities for a long time. The challenges are they're low yield. You're not getting 8 2x8s out of a 4-inch top piece of wood. You're getting 2x4s. That's your bread and butter. And and it's short 2x4s. You're not even getting 16-footers. It's 10 foot. That's as long as they can be. So it's low yield. It's high bark chip ratio. So you're buying wood in at a premium price, most of the time above pulp prices, but you're returning a fairly large ratio back to the pulp side of things. So that's something we have to pay very, very close attention, especially with the biomarket, or the byproduct markets are volatile. Sometimes mills want it, sometimes they don't, sometimes they pay through the nose for it, and sometimes you can't give it away. So it's extreme to run that style wood with this spec. We've tried it at Milan, which is our flagship. My mill manager there was telling me we are never doing that again. It absolutely destroyed his numbers. His mill is not designed for it. It's all production based. So when you take a 275,000 board foot a day production and knock it down to 120, Mr. Carrier knocks on the door, gives you a call, like, what is going on here? So that's part of the reason why we built a facility that will take that, that's designed for that. Milan is not. Luzon is definitely not. They're the opposite. They like full-size wood, plenty of meat on the bone. This stuff, not so much. There tends to be a high amount of defects. I don't know. Once again, I look at the foresters and the loggers, and I'm not sure why you guys would be stuffing out of spec wood in this, but it tends to be higher percentage. Push and spec, knots, crooked, broke, split, whatever the problem is. It just tends to be a little bit higher than your first cut loss. But there is opportunities here, and just as much as pulp is a challenge, it can be an opportunity too, because now it's made us more diverse. We have more connections. Some of this goes to Canada, some of it stays in the U.S. We produce products for niche markets, especially during COVID. One that I never really thought of. There was a lot of really weird, like 101-inch boards, 2x3s, 101 inches, and it was for campers. You could not sell it fast enough during COVID. It was like the whole East Coast was wiped out of it. You could not buy a 2x3 by 101 inches. Not that you usually want to anyway, but it was part of this mill was designed to help. We deal in I can't remember the name. I think it's Forest River or one of those, but it's out in Elkhart, Indiana, and we ship a tremendous amount of wood out there for campers, just for the construction of campers. So finding these niche markets are key to be able to make our these bottom lines work, so we can continue to purchase wood from Scott. The other key part was back when I was still an operations forester, the technology was not there to make these mills efficient enough and collect enough profitable material to make it worth the investment. These are not cheap facilities to buy or build or run or maintain. And with the generation of AI and how software has advanced through time, the speed of which software processes information is exponentially faster than it was 10 years ago. With that computing capacity, along with the tech and the scanning capability, that's a big part of why we can do what we do for that small diameter wood. The other thing is we try to do, maintenance is huge. When you have such a small employee base like we do in Woburn, everything needs to be automated in some way to help reduce what each employee that is there has to do. So it's a ton of engineering and designing on how can we eliminate this, how can we eliminate that, and make it seamless and one person can handle more jobs. So our production capabilities. So the Hughes saw is capable of running at 700 linear log feet per minute. That's max to the max to the max. We run generally around 600, hardwoods down around 450 linear feet per minute. So that equates out to, and these are softwood numbers, not hardwood or larch or anything like that. But so that mill is capable of 100. On average, it produces 160,000 board feet per day. That's 36 million board feet per year, and then it eats 15,000 logs a day, which is a lot of little tiny logs. And then you get 3.45 million of those I got to come up with. And that's a lot of little ones. So Scott needs to keep doing what he's doing. Mill has the capability to run other species, like I said, hardwood, larch, and popple. Those are mainly for pallets. We have a pallet facility in Henniker, New Hampshire, in HHP. This facility was also built during COVID when there was a massive drought in the availabilities for pallets. Our pallet facility was running out of wood consistently. So this mill was also, we can shift that over to hardwood and make cants for our pellet facility in Henniker, New Hampshire. So this facility currently has 11. I think they need 13. They would like to have 13 people total. Right now, 11. That's including one of the owners as one of the employees there working. They work 10-hour shifts with a half-hour off for lunch 5 days a week. They produce that wood with that many people, with that few people. So the products, like I was talking about earlier, is hundreds of patterns. Everything's all software. Every way you can have a log and scan it and look at it and produce something out of it, it has a pattern for it. So if the video was working, it has a cylinder that turns back and forth, orienting the logs to go into the Hughes saw at kind of staggering speed, how fast it's figuring all this stuff out. But we try to recover, right down to 1x. We'll do strapping. We make our own stickers. Anything we can do to utilize as much of these products as we can. Our niche markets, like I was saying before, they're all weird. They all want something special. So with this mill, we can make that happen as long as it's not exceeding 10'6". Like 2x3x9, that was the camper stuff. And then we're collecting down to 4 feet for pallet stock or other, anything. But the key is our flexibility. So we can change by simply letting whatever softwood's in it run out and move it over to hardwood. And just change the computers over and say, now you're running hardwood, and it runs hardwood. Everything's all preset. We've done all of our testing. So as simple as in an hour, I can change this mill and say, oh no, we need to go do something else. They can go do something else. It may not be running. It might take a minute to get it perfect, but we can physically change this system over fairly quick. So once again, it's the use of technology is helping us save in our labor costs. The use of AI, the use of the extra planning, all the computer, it's making us more labor efficient, and we're also being more accurate when we're producing these goods. Our accuracy on making sure that each product is going into the correct category, that's it's an upsell for that. We have conveyors underneath this entire system that collects all the debris and sends it out to the chipper to be, for biomass or whatever it is going to be used for. So somebody doesn't have to be under these machines sweeping it. We don't have to shut down to sweep it. It collects it all, takes care of it. We clean up maybe once a week on Friday afternoons, a little bit of sweeping. The whole place it automatically greases itself. Every so many revolutions of this particular bearing is so much grease is applied to that particular bearing, so that you don't have to shut the mill down and have somebody out there with a grease gun greasing it. there's only a few places that they couldn't get to that need to be greased by hand. So it's little things like that is saving our ability to run Scott's wood. But, so in conclusion, it's literally technology that has made this possible. Without the tech change, I'm not sure we'd still be running small diameter wood. But thank you. My name's Seth. There's my information if you guys wanted to see anything. I know I'll probably run over a little bit, Ray, but you guys got any questions or?
Questions for Seth?
Love it.
Your customers, everyone under the sun, or big box stores, or whoever will buy it pretty much?
We sell to anybody who wants to. They call us up and if we can come to a deal, they can get it. Like I said, it was weird stuff like going to Mexico. We've sent stuff to the West Coast. It's anybody and everybody is, welcome. We don't shy away from that. So. Yes, sir. I do. I run red pine. Well, I can't there. I can in Milan. There, it's a deed problem. When we bought the facility, the previous owner was a pine mill, and they've restricted us in the deed. We can't run pine. So, I'm trying. We're working on it. It's lawyers and all that stuff, but maybe. Yes, sir. It's transportation costs go. Yeah, you need to be fairly close to the mill to make it work. If I push too far, I can't pay enough to offset it, and then I'm paying too much for the wood just for transportation.
Any other questions? You guys want to take a break? Come back at 3.